Okay, so in this video I'll be recording solutions to the 2018 Mathematical Methods VCAA Exam 2. Exam 2 in Maths Methods is a 2-hour examination comprising 20 multiple choice questions and 60 marks worth of extended answer questions. It usually is either 4 or 5 extended answer questions. This year it is 5. In exam 2 you can use a CAS calculator, which I've got open here, and you can also refer to your bound reference of notes. So let's get started on the questions. Instructions for the multiple choice questions, pretty standard, circle, you have to answer on the answer sheet, colour in one correct response. No answers if you circle in more than one, colour in more than one circle, no mark if you colour in more than one circle, and 1 mark if you colour in the correct circle. Okay, let's have a go through the multiple choice. So the period of this function is, so it's a cos function, period is all to do with this coefficient of x. So we know period is 2 pi divided by n. In this case, n is 2 pi on 3. So that is 2 pi multiplied by 3 on 2 pi. The 2 pi's cancel out and we get a period of 3. Maximal domain of the function is r excluding 1. A possible rule for f is. Okay, so definitely r excluding 1 would be the domain of that function. R excluding 5 would be the domain of that function. The domain of that function would be r. There's no problem there. Domain of that would be r excluding negative 1. This would be x minus 1 has to be bigger than 0, so x bigger than or equal to 0, so x has to be bigger than or equal to 1. So option A, it's all about what value would make the denominator 0, or in the case of the square root, what would make the number under the square root negative. And so this is the one where x equals 1 would be a problem, which is why 1 is being excluded from the domain. Obviously you could plot all those graphs on your CAS and see which one gives you that domain, but that would be a very cumbersome way to try and answer that question. Question 3. Consider the function with domain from a to b inclusive of a, not inclusive of b, and the rule is y equals 1 on x, where a and b are positive real numbers. The range of f is. Okay, so 1 on x is a hyperbola. If a and b are positive, we're really only looking at the right hand side here. So if the domain goes from a to b, let's say that's a, let's say that's b, inclusive of a and not inclusive of b, we're talking about that bit of function there. When x equals b, y is 1 on b. When x equals a, y is 1 on a. So the range is going to be from 1 on b, but not including 1 on b, up to 1 on a, but including 1 on a. So D. Okay, question 4. The point A32 lies on the graph of the function f. A transformation maps the graph of the function f to the graph of g, where g of x is half f of x minus 1. The same transformation maps the point A to the point P. The coordinates of P are. Okay, so we want to be able to identify these transformations. This is a relatively routine sequence of transformations, and hopefully you can see that that is going to be a dilation by a factor of 1/2 from the x-axis. That's the half out the front. And the minus 1 inside the function is a translation to the right by 1. So that means if we were to apply that to a point, if you take the point x, y, you dilate it by half from the from the x-axis, you're halving the y coordinates. And if you translate to the right by 1, you are adding 1 to the x coordinates. Okay, some students get confused about the fact that it's subtracting 1 in the rule, but what's happening to every point on the graph is that if you're moving it to the right by 1, you take a point, you move it to the right by 1, you add 1 to its x coordinate. And so therefore, if we have the point A, which is 3, 2, and we apply these transformations to it, we get to 3 plus 1, half times 2, and so that is 4, 1. So the coordinates of P are 4, 1. So option C. Consider f, which is x squared plus p on x. p is a real number, x can't be 0, otherwise there would be a problem here. There is a stationary point on the graph of f when x equals 2, the value of p is. Okay, so you could probably do this by hand without too much cause. I think it would probably be slightly quicker potentially to do it with your CAS. So if I define that function and then the stationary point on the graph of f when x equals -2 tells us that f dash of -2 is equal to 0, and then we should be able to solve that to find p. So you might choose, it's a bit easier when you have to substitute numbers into a derivative, it's a bit cumbersome in the CAS, so it's a bit easier sometimes to actually just define the derivative function. I usually use a convention where I define it as d, whatever letter the original function was, so df of x I'm going to define as being the derivative. So define that as the derivative of f of x, and then we can solve the derivative. It's just easier to substitute into it when you define it as its own function. Derivative of f at -2 equals 0 for p. And we get p equals -16. So I know that was a little tedious with the CAS, but I also think it would probably have been almost as slow by hand. I mean, obviously, you know, you have to start by thinking about f of x is x squared plus px to the -1. So your derivative is 2x minus px to the -2. Which is 2x minus p on x squared, and then f dash at -2 is 2 times -2, which is -4 minus p over -2 squared, which is 4, and that equals 0, and then solving from there. So perhaps multiplying everything by 4 is -16 minus p equals 0, and so p is going to be -16. So perfectly possible by hand. It's just about what is most efficient, and that's where you've got to get better at making good decisions around your CAS, what's going to be quicker. As I said, if you hadn't defined the derivative function with your CAS, the solving would need to be, and this is where you need to be a bit careful because you actually need to put a bracket before you start, and if you don't put it at the beginning, you have real trouble getting it back in there. Derivative with respect to x of f of x outside of the derivative bracket, given that x is equal to -2, and then all of that has to be equal to 0. So the reason you need that first bracket is because you need this bracket here after the -2, so that you don't just have a part of your function that says -2 equals 0, which is ridiculous. So it can be quite clumsy to enter that in, hence why it's often quicker to define the derivative as its own function, and then it's easier to solve and work with it. Okay, regardless, the answer is A. Question 6, let f and g be two functions such that f of x equals 2x, g of x plus 2 is equal to 3x plus 1. The function f of g of x is equal to. Okay, so from here we kind of need to be able to work out what g of x is. So g of x is going to be if we take g of x plus 2 and take away 2 in there. Okay, which means all we're doing is taking the existing function and subtracting 2 just from the x values. So all we're going to do is have 3 times x take away 2 plus 1. Okay, so g of x will have the rule, what's that going to be, 3x minus 6 plus 1, so 3x minus 5, and so therefore then f of g of x is about substituting 3x minus 5 into f of x, so it's going to be 2 times 3x minus 5, which is 6x minus 10, so option D. Okay, question 7. Let f, it's got a domain of positive real numbers. F is the function k times log 2 of k, where k is any real number. Given that f of inverse f of 1 is equal to 8, the value of k is. Okay, so the most useful way to use this information is if the inverse function goes through the point 1,8, that means that the original function goes through the point 8,1. Okay, inverse function is just switching x and y. So if the inverse function goes through 1,8, the original function goes through 8,1, and then we can use that to find k. Okay, so f of 8 is going to be k times log 2 of 8 equals 1. Log 2 of 8 is 3. And so k is 1/3. Obviously, you could get your CAS to solve this equation for you, but to me that's more efficient by hand. And again, that's about that good decision making. Okay, if the integral from 1 to 12 of g of x is equal to 5, and the integral from 12 to 5 of g of x is equal to -6, then the integral from 1 to 5 of g of x is equal to what? Okay, so the first thing I'm seeing here is that this would mean that the integral from 5 to 12 of g of x is +6. Okay, and so therefore if we know that the integral from 1 to 5 of g of x plus the integral from 5 to 12 of g of x will be the same as the integral from 1 to 12 of g of x. And we know we're trying to find, this is what we're trying to find, that's the unknown. 5 to 12 we just worked out is 6, and that's going to equal 5. And so therefore the integral that we're trying to find, which I just called a nominally, has to equal -1. So B. Question 9. A tangent to the graph of log e of 2x has a gradient of 2. The tangent will cross the y-axis at. Okay, so we need to find the equation of the tangent. So we know it has a gradient of 2. So we need to first of all find the x coordinate. So we want to know when will the derivative be equal to 2. Okay, and that's going to give us an x value. So perhaps in this case I might define this function. F of x equals log e of 2 times x. Okay, so I need to solve the derivative equal to derivative of f of x equal to. Now, I didn't bother to define the derivative as a separate function here, and that's because I'm not trying to solve the derivative at a point equal to something. That's where things get really ugly. So for me, it doesn't save a lot by defining the derivative as a separate function here. Okay, so that happens when x equals 1/2. So the gradient is 2 when x equals 1/2. So therefore, we want the tangent when x is equal to 1/2. So menu 4(9) for tangent line, we want the tangent to f of x when x is equal to 1/2. And the tangent has equation y equals 2x minus 1, and that clearly intersects the y-axis when x is equal to -1. So C. Question 10. The function f has the property f of x plus f of x equals f of 2x for all non-zero numbers x. Which of the following is a possible rule for the function? Okay, to me these are just quite tedious. Personally, I always just use my CAS to do these. This is quite a complicated one. You're subbing the function into itself plus x. You might be able to think it through a bit logically, but in all honesty, I don't even stop to think. I just work these out. Okay, so I'm going to, menu 1(1), I'm going to define the function in part A, which is 1 minus x, and then I'm going to get my CAS to work out this, and if it is true for all x values, it will tell me true, and if it isn't true for all x values, it will give me some kind of equation involving x. So I'm looking for it to tell me true, and then I'm done. So I'm simply going to type it in. So it's going to be f of x plus f of x equals f of 2x. Okay, so the fact that it gave me an equation tells me that that is only true when that equation is true, which is going to be, if we solved that for x, that's only true when, so this relationship is true for this particular function, but only when x is equal to, what will that be, 1/2. Okay. We want it to be true for all real numbers x. We want it to say true when we type it in. Okay, so now it's a bit easier once I've done that once. I'm just going to redefine my function. So I'm going to define f of x now as being x minus 1. And I'm going to enter the same expression in, but I'm not retyping it, just scrolling up, pressing enter. Okay, so that's never true. So that's not an option. Again, I'm going to define, and you might find it quicker to do menu 1(1) and just define a new function again. I'm going to edit that, define equals x. Okay, that's true. That's true for all real x values. So C. If you want, you can check the others just to make sure that you haven't made any kind of error. So divide that by x earned 2, No, that would only be true when that equation, when x is equal to whatever makes that equation true, which I think is really just going to be 0. And then last one we can check would be 1 minus x on 2. There's the function, also not true for all values of x. So C is our only correct option there. Okay, question 11. The graph of y equals tan of ax, where a is a positive real number, has a vertical asymptote x equals 3 pi, and has exactly one intercept in the region 0 to 3 pi. 1x intercept, sorry, in the region 0 to 3 pi. The value of a is. Okay, so tan of ax, as long as a is a positive number, would have a period of pi on a, and therefore an asymptote at x equals pi on 2a, halfway, and it would do this. Okay, and then obviously there would be another asymptote and another intercept at, what will that be? 2 lots of pi on a, and so let me think about that, 3/4 of that, so it's going to be x equals 3 pi on 2a. And then the graph continues. Okay, so the graph of y equals tan of ax, which I've just drawn here, has a vertical asymptote at x equals 3 pi and has exactly one intercept in the region 0 to 3 pi. Okay, so what that means is, alright, so in order for it to have one x-intercept in the region 0 to 3 pi, not including 0, so there is an intercept at 0, but we're not counting that's not counted in here, so we need an intercept somewhere between 0 and 3 pi. Means that it has to be this intercept. So 3 pi has to be somewhere past here. Okay? So otherwise, we're not going to have one x-intercept. If 3 pi was somewhere between pi on 2a and pi on a, we wouldn't have one x-intercept in that interval. So we know that x equals 3 pi is going to have to be somewhere between this value, these two values. Okay, so we know that 3 pi, well actually, but we know that 3 pi has to be an asymptote. So therefore, 3 pi either has to be equal to pi on 2a, or it has to be equal to 3 pi on 2a, or any of the other asymptotes, okay? But if 3 pi were to equal pi on 2a, then you wouldn't have an intercept between 0 and 3 pi. So therefore, 3 pi must be equal to this particular asymptote here. So 3 pi has to be equal to 3 pi on 2a. If we divide both sides by 3 pi, that's 1 equals 1 on 2a, and so 2a equals 1. And a therefore has to equal a half. So C is the correct answer to question 11. Okay, question 12. The discrete random variable x has the following probability distribution. So this question is not relevant in 2020. This is part of the sections of the syllabus that were removed. But I'm going to answer it for those of you watching this in the future. Let mu be the mean of x. The probability that x is less than mu is. Okay, so we need to work out the mean, mu. So mu is the expected value of x, which in this case is 0 times 1/4 plus 1 times 9 on 20 plus 2 times 1 on 10 plus 3 times 1 on 20 plus 6 times 3 on 20. Okay, so we can probably get our cows to do that for us. So 9 on 20 plus, so I'm skipping the 0, and that's 2 on 10 plus 3 times 1 on 20 is 3 on 20 plus 6 times 3 on 20 is 18 on 20. Okay, so the mean is 17 on 10, or 1.7. Okay, so then we want the probability that x is less than 1.7. Okay, so that means x can either be probability x equals 0 or probability that x equals 1. They're the only two discrete values within that interval. and so therefore that's a quarter plus 9/20. A quarter is 5/20 plus 9/20, and so that is 14/20 or 7/10, which is 0.7. So option E for question 12. Okay, question 13. In a particular scoring game, there are 2 boxes of marbles and a player must randomly select 1 marble from each box. The first box contains 4 white marbles and 2 red marbles. The second box contains 2 white marbles and 3 red marbles. Each white marble scores -2 points and each red marble scores +3 points. The points obtained from 2 marbles randomly selected by a player are added together to obtain a final score. What is the probability that the final score will equal 1? Okay, so let's just sort of think about what selections can happen first and then worry about the scores. So first box has, so we've got white or red marbles, we've got 4 whites and 2 reds, so that's 4 out of 6, which is 2/3, versus 2 out of 6, which is 1/3. And then the second box has 2 white and 3 reds, so we're also choosing whites and reds. So what did we say? So 2 whites and 3 reds, so 2/5 and 3/5. White and red, 2/5 and 3/5. Oops, 2/5 and 3/5. Okay, let's think about the scoring. So each white marble scores -2 points and each red marble scores +3 points. So that would be -2, -2, and then we add the scores together. So that would give an overall score of -4. A white and then a red would be -2 plus 3, so that would give +1, which is what we want. A red and then a white would give +1, which is what we want, and a red and then a red would give, would give +6, which is not what we want. So we're interested in, we want these 2 branches. So the probability of getting a score of +1 is, so the probability that the score equals +1 is the probability of getting a white and then a red, or the probability of getting a red and then a white, which is 2/3 times 3/5 plus 1/3 times 2/5. Keeping the common denominator to make it easier to add them, so that's 6 on 15 plus 2 on 15, which is 8 on 15. So option E. Okay, question 14. 2 events A and B are independent, where probability B is equal to 2 times the probability of A, and the probability of A union B is 0.52. Probability of A is equal to. Okay, so when we have independence, we know that the probability of A intersection B is equal to the probability of A times the probability of B. Now, if we use this fact, we know the probability of B is the same as 2 times the probability of A. So that is the probability of A times 2 times the probability of A, which means it is 2 times the probability of A squared. Okay, so maybe let's let, just to make the maths a bit easier, let's let x equal the probability of A. So therefore, I can write this then as probability of A is x times the probability of B, which is 2x, and so that's 2x squared. Okay, then if we think about using the union, so we know our addition rule for probability says the union is the probability of A plus the probability of B, take away the probability of A intersection B. Okay, so therefore that is 0.52. Probability of A we've called x, probability of B we know is 2x, and the probability of the intersection is 2x squared. So we want to solve that equation for x. We can just get our cows to do that for us. We don't need to go any further. It's going to be quadratic with a decimal. It's not very nice. So 0.52 is equal to, I haven't even bothered to collect those together, but that's okay. X plus 2x, you can write 3x if you want. Take away 2x squared, and we are solving that for x. And that gives us x equals 0.2 or 1.3. Obviously x has to be between 0 and 1, so x must be 0.2. So that is the probability of A. Probability of A must be equal to 0.2. So B. Okay, question 5. A probability density function f is given by this function here. The median of this function satisfies the equation. Okay, so again, not relevant to 2020. but I'll work through this problem regardless. So the fact that it's not asking me to find the median means that my CAS is going to be of limited use. I actually need to sort of get halfway through the process of finding the median so I can work out which of these equations is needed. Okay, so to find the median, we do the integral from 0 up to the median of the function. Will be equal to half. Okay, so we could take out that 1/12 and move it over to the other side, so we can essentially say the integral from 0 to m of 8x minus x cubed dx, multiplying both sides by 12, is equal to 6, which might be a slightly easier thing to work out. Alright, so this is 8x squared on 2, so that's 4x squared, minus x to the 4 on 4 from 0 to m equals 6. Okay, so we've got 4m squared, take away m to the 4 on 4, and then take away, well, that'll be 0 when we sub 0 in, which is good, and that equals 6. Okay, so we're getting there. So 4m squared minus m to the 4 on 4 equals 6. If we multiply everything by 4, we're going to get 16m squared minus m to the 4 equals 24. And then rearranging that just to check which of these it's going to work, I'm going to add everything all over onto the right, so it'll be 0 equals m to the 4, take away 16m squared, plus 24. So option E. Okay, question 16. Jamie approximates the area between the x-axis and the graph of y equals 2 cos 2x plus 3 over the interval 0 to pi on 2 using the three rectangles shown below. So it's a right endpoint estimate. Jamie's approximation as a fraction of the exact area is... Okay. So we're going to need to know the coordinates of those points. Okay. You could do that by hand, but it might be easier, given you're going to do 3 of them, to do them with your CAS. F of x equals 2 times cos. If you know your exact values very well, this might be more efficient for you to do by hand, but that's a decision to be made. Okay, so f of pi on 6, oh sorry, I'm in degrees. Alright, try again. F of pi on 6 is 4, so this is the point pi on 6, 4. F at pi on 3 is 2, and f at pi on 2, I'm going to guess is going to be 1, but let's see. F at pi on 2 is 1, good. As I said, depends how readily available in your own mind your exact values are. But yeah, so there's our 3 points. So we want Jamie's approximation as a fraction of the exact area. Okay, so we need the exact area, which is going to be the integral from 0 to pi on 2 of the function. So actually, not a bad thing that I defined it. Shift plus integral from 0 to, sorry, not 2, pi on 2. Pi on 2 of f of x with respect to x. So that is 3 pi on 2. And then the approximate area. So each of those rectangles has a width of pi on 6. And so we can just do pi on 6 times the sum of the heights. So 4 plus 2 plus 1, because that's the same as doing pi on 6 times 4 plus pi on 6 times 2 plus pi on 6 times 1. So 4 plus 2 plus 1 is 7, so it's 7 pi on 6. And so then we want Jamie's approximation as a fraction of the exact. Okay, so we want approx over exact, means it's going to be 7 pi on 6 divided by 3 pi on 2, which is 7 pi on 6 times 2 on 3 pi, cancelling down the 2's, and we can also cancel down the pi's. We're going to end up with 7 on 9. So option B. Okay, question 17. The turning point of the parabola y equals x squared minus 2bx plus 1 is closest to the origin when? Okay, so this is about minimizing distance. Minimize the distance between a point on that function and the origin. Okay, so essentially you've got some kind of quadratic, don't know what it is, don't know where it is, you've got the origin, you've got a point on your quadratic which would have coordinates of x, and the x coordinate is x, the y coordinate is x squared minus 2bx plus 1, or we could just call that f of x. I'm going to call this function f of x. It's just going to make my notation a bit easier. Okay, I'm going to define the function in my CAS, menu 1.1. Define f of x equals x squared minus 2 times b times x plus 1, and so then the distance is going to be the square root of x minus 0 squared plus f of x minus 0 squared. It's just simple Pythagoras if you don't remember your distance formula. You know, rise squared plus run squared equals hypotenuse squared, essentially. Okay, so I'm going to define that function with my CAS. I'm going to define d of x as being the distance, and it is the square root of, that's just x squared, isn't it? X squared plus, and that's just f of x squared. I've defined my function, so that's all fine. Whoops. F of x all squared. Okay, so it doesn't really matter what that is. To minimize, we want to solve the derivative of that equal to 0. Okay. So I'm going to solve shift minus, so derivative with respect to x of d of x equal to 0 for x. My apologies. Sorry, I've misread the question. The turning point of the parabola. Okay, so it's not just a general point, it's the turning point. So we first of all need to focus on getting an equation for the turning point. So let's do that. Or getting, not an equation, sorry, getting coordinates of the turning point. Okay, and the best way to do that is to complete the square. So menu 3.5 to complete the square. We want to complete the square for our function which we've got defined. You need to put comma x with completing the square. Okay, so completing the square tells us that y is equal to x minus b all squared minus b squared plus 1, sorry. And so that means that the turning point has coordinates of b and negative b squared plus 1, so I might write that as 1 minus b squared. So that's the coordinates of the turning point. Okay, so then it's the distance between the turning point and the origin. Okay, so it's the distance between those 2 points. Good, because we had too many unknowns with the b. Okay, so the distance now, my apologies, is b minus 0 all squared plus 1 minus b squared take away 0 all squared. Okay, so that's just b squared plus 1 minus b squared squared. So, right, I'm going to define that function instead. So define our distance function as being the square root of b squared plus 1 minus b squared squared. Okay, so now we want to solve the derivative of that equal to 0 to minimize it. Sorry, and it's not d of x, it's d of b. I'm going to have trouble with that. So it's distance in terms of b. Nearly there? Okay, there we go. Okay, so we want to solve shift minus the derivative with respect to b of d of b. We want to solve that equal to 0 for b. Okay, and we find that b equals negative root 2 on 2, which is the same, given what we've got here, I'm going to write that as 1 on root 2. Negative 1 on root 2, 0, or positive 1 on root 2. Okay, so we want to know which value of b gives the minimum. Now, you might want to try and have a look at the graph of the distance function. So if I type d of x in here, it'll allow me to see it. So I can see that the minimum points of the distance function are at plus minus 1 on root 2. If I have a look, we can make this a bit smaller here so we can kind of see a bit better, if that helps. So the minimum values are clearly not at 0. It's a maximum turning point at 0, and the minimum values of d happen when b is plus or minus 1 on root 2. Okay, so min d is when b is equal to plus or minus 1 on root 2. And so option C will make sure that we are minimizing the distance between the origin and the turning point of the parabola. Okay. Question 18. Consider the functions. Alright, so we've got these two functions here, both power functions with fractional powers. P, Q, M, and N are all positive integers, and P over Q and M over N are fractions in simplest form. If the set of x values where f of x is bigger than g of x is between 0 and 1, and the set of x values where g of x is bigger than f of x is from 1 to infinity, which of the following must be false? Okay, so essentially what we need to be happening here is whatever they look like between 0 and 1, which way f is bigger than g between 0 and 1. So they've both only got a domain of the positive real numbers, so they don't exist at 0. Whatever is happening, they're obviously intersecting at 1. Okay, so that means, and which one's bigger again, sorry, f is higher, so that one's f of x, and that one's g of x. Now, I haven't even thought about the shape. They might be curving in a different direction. I haven't thought clearly about that. But essentially the key is in terms of which one is higher than the other one. So what that would mean is g of x has to have a bigger power than f of x. Okay, and that's because if you have a fractional value raised to a bigger power, it's smaller. If you have a number bigger than 1 raised to a bigger power, it is bigger. Okay, and so what that tells us is the power of g of x, which is m on n, is going to have to be bigger than the power of f of x, which is p on q. Okay, so if we multiply both sides by q and multiply both sides by n, we know they're all positive, so that's not going to switch around the inequality. So m times q is bigger than n times p. Okay, so let's see if we can narrow some of these out. So we want to know which of these must be false. So q is greater than n and p is equal to m. Okay, if p were to equal m in this inequality, that would essentially cancel them out. We could divide by them because they're the same thing, and it would leave us with q bigger than n. So that's true. Okay, as long as if p is equal to m, then q is bigger than n. M greater than p and q equals n. So again, if q were to equal n, those would cancel out, and m would indeed be bigger than p. So that would be true. Okay, so the point is it's true for some values of m, q, n, and p. We need to know which one must be false. No matter what m, p, q, and n are, which one must be false. Pn is less than qm. Yes, that's just this statement written the other way around. So that's true. Okay, so then the derivative of f at c is equal to the derivative of g at c for some value where c is between 0 and 1. Okay, yeah, there should be. If I've got my shapes happening right, given that they have to meet at 0 and meet at 1, but curve away from each other in between there must be a point somewhere where the gradient of that is the same as the gradient of that. Sorry, I haven't drawn those in the same place. But there must be a point somewhere where they have the same gradient. Okay, so yeah, that must be true for some value c. And then the derivative at d is equal to the derivative at g. Sorry, derivative of f at d is equal to derivative of g at d for some value where d is bigger than 1. Okay, so if d was out here somewhere, Now the point is that one's going to continue to get steeper and one's going to get less and less steep because of the difference in their powers. So there shouldn't be anywhere out here where they actually have the same gradient, because the gradient's continuing to increase here and getting less and less steep here. So that one wouldn't be true. And by process of elimination, we hope that that one wouldn't be true. So E. That one's quite tough. There's quite a lot of reasoning to get through that. Possibly not worth spending time on for some of you. It would be better to invest your time elsewhere. Okay, so question 19, getting to near the end of the multiple choice. The graphs of f and g, so a cos function and a sine function, are shown in the diagram below. An integral expression that gives the total area of the shaded regions is. Okay, so there's a couple of different ways that we could express this. One of the key things I think is going to be to do with the fact that those two regions will be equal. So we're probably only going to have one integral doubled to get those two regions. So I would be saying, well, that's the integral from 0 to a third of, which one's which, f of x minus g of x. That is the integral from 1/3 to 1 of g of x minus f of x. That is the integral from 1 to 5/3 of f minus g, top minus bottom. Remember, it doesn't matter where the x-axis is, it's just always top minus bottom. And then this bit would be the integral of from 5/3 to 3 of g minus f. Okay, so let's see what's happening here. It's definitely not just going to be the integral from 0 to 3. Nor is it going to be 2 times the integral from 5/3 to 3. This bit of area here is unlikely to be equal to those other 3 bits of area. Okay, so now which one's which? I've just written f and g. Cos is f and sine is g. Okay, so this is f and g, this is f and g, and this is f and g. Okay, so they've written the integral from 0 to 3 of f minus g, so that is the first bit, minus, okay, 2 lots of the integral of f from 1/3 to 1 of f minus g. Okay, now if we were to swap these around, so if I was to swap these around up here, then I would have to stick a negative out the front, which is what this negative out the front's doing here, because they've got the functions around the other way, f minus g. So it's the negative integral from 1/3 to 1 of f minus g would be this bit of area up here, and they've doubled that because it's also going to be the same as that bit of area there. This one's looking okay to me. And then this one, again, they've done minus because they've done f minus g where it should be g minus f. That's what the negative is for, 5/3. So I think it is C. Let's just see if we can rule out the others. Integral of, so again, which one? So this is f and g. Integral from 1 to 5/3, 2 lots of the integral from 1 to 5/3 of f minus g. Okay, so that would definitely give you these 2 small regions, that bit. Okay, that's correct. And then take away 2 times the integral from 5. Okay, so we wouldn't be doubling this bit of area here. That's not going to make sense. And then E, the integral from 0 to 1/3 of, again, which one's which? Cos is f, so that's f minus g. That's correct. Plus 2 lots of the integral from 1/3 to 1 of g minus f. Okay, yeah, that's how I would have written it. So that's also good. That's the 2 bits in the middle. And then the integral from 5/3 to 3 of, now if it's f minus g, you either need to switch these limits around or make it a negative, so it should be minus for that to be correct. So this one's not correct. So C for question 19 should be correct. Okay, and then the last multiple choice. The differentiable function f is a probability density function. It is known that the median of the probability density function is at 0 and f dash at 0 is 4. The transformation maps the graph of f to the graph of g, where g is a probability density function with a median at x equals 0 and g dash at 0 is negative 1. The transformation could be given by. Okay, so the first thing to note is they both have the same median, which means that there's no translation. And actually looking at the options in the multiple choice, there's clearly no translation. All there is dilations from the x and y axis. Okay, so the gradient of the original function, so we're mapping from f to g, so the gradient of f at 0 is 4, and then the gradient of g at 0 is -1. Okay, so regardless of the size, we'll think about that in a minute because that's to do with the dilations, the size of the gradient's changing. But the fact that the gradient goes from being positive at 0 to being negative at 0 means that there must be a reflection in the y-axis. It could be a reflection in the x-axis, but that wouldn't, then you'd have an issue with the probability density function, because probability density function has to be above the x-axis, okay, and so you can't reflect in the x-axis and still have another probability density function. So it must be reflected in the y-axis, but obviously there's also dilation, which is why the actual slope of it is changing as well, and that's what we need to think about next. So we definitely have a reflection in the y-axis, which means the x coordinates have to get multiplied by a negative. So that doesn't happen in B, that doesn't happen in C, and that doesn't happen in E. Okay, so then we've got two options here. So if we think about what happens with gradient, so gradient is sort of change in y over change in x, right? And for f, it's 4. And then for g, the change in y over the change in x becomes -1. So if we were to, let's think through A. Forget about the negative, we've already adjusted for that, okay? So let's just focus on the size of the gradients then, okay? Doesn't really matter. So if we were to use A, we'd be doubling all the x values. So the change in x would get doubled, and we'd be halving all the y values. Okay, so the change in y would get halved. Okay, which would mean if we did that, if we did A, we would be, what did I say? Halving all the y values. So change in y times a half, change in x times 2. So if we just focus on that, a half divided by 2 is a quarter. So we've essentially got change in y over change in x times a quarter. Now, if we were to multiply this by a quarter, it is going to get us to this. Now, obviously, it's actually -1. In fact, we're multiplying all the x values by -2, so why don't we just include that in here? So we're multiplying by -1/4, which would mean that we get -1, which is what we want. If we did option, let's just check that D doesn't work. If we did option D, we'd be multiplying all the x values by -half. So the change in x would get multiplied by -half, and the change in y would get multiplied by 2, which would mean we essentially have change in y over change in x multiplied by 2 divided by -1/2 is 2 times -2, so multiplying by -4, which would give us -16. So that one's not going to work. So we want option A. It gives us that reflection in the y-axis and dilates the graph in such a way that the gradient is going to go from being 4 to being -1, which is what we want. So A. So again, that's another quite tough one towards the end, but you would expect that in question 20 of the multiple choice. Okay, so that's the multiple choice questions. We'll continue on with the extended answer questions. Okay, so section B, the standard instructions as usual, the two to be really mindful of as always, particularly when you have your CAS. In all questions where a numerical answer is required, an exact value must be given unless otherwise specified, and in questions where more than 1 mark is available, appropriate working must be shown. Okay, so a 2-mark question needs more than an answer, and if you're not told to give a rounded value, don't give a rounded value. Okay, let's work through the questions. Question 1 is worth 13 marks, and we have a quartic function. So the first thing I'm going to do here, let's get rid of all of that. Let's get over here, clear that off. Let's define a function, f of x equals, before I've even read anything, it's a 13-mark extended answer question, all to do with this function. The first thing I'm going to be doing is defining the function. 3x to the power of 4 plus 4x cubed minus 12x squared. So consider the quartic, part of the graph is shown below. Find the coordinates of the point M at which the minimum value of the function occurs. Okay, so perhaps the quickest way to do this with my CAS would be to use, rather than solve derivative equal to 0, would be to use function minimum instead, because we want the absolute minimum of the function. So function minimum, of f of x, comma x. Okay, so that happens when x equals 2, and then, negative 2, which matches with what we're seeing on the graph, and f of negative 2 is negative 32. Okay, so m is negative 2, negative 32. State the values of b, for which the graph of y equals f of x plus b has no x-intercepts. Okay, so if we were to translate the graph up so that the turning point was past the x-axis, then the graph would have no x-intercepts. Okay, so therefore we need to translate the graph up, not by exactly 32, because that would mean there'd be an x-intercept on the x-axis, so we want to translate up by more than 32, and so therefore b has to be bigger than 32. Okay, part C. Part of the tangent L, so the tangent is called L, to y equals f of x at x equals negative a third is shown below. Find the equation of the tangent L. Okay, so tangents, I find students constantly do them by hand when the CAS can do them for you. Menu 4.9, tangent line, tangent to f of x, comma, when x is equal to, was negative a third, wasn't it? Negative 1/3. And there we go. So the equation, so you must give an equation, you can't just write an expression. The equation of the tangent is y equals, it's not L equals, you might be able to write L of x if you want, but it's y equals 80x on 9 plus 41 on 27. The tangent L intersects y equals f of x at x equals negative a third and two other points, so we can see that on the graph. State the x values of the two other points of intersection. Express your answers in the form where a, b, c are integers. Now there's 2 marks here. I doubt that the 2 marks are for the 2 points. I think the 2 marks would be for some process, which is solving an equation, and the equation I need to get my CAS to solve is f of x equals 80x on 9 plus 41 on 27. So I'm going to be solving f of x equals this up here, 4x. Okay, and when I do that, I get x equals, now your CAS, and this is a bit, I think, VCAA trying to force you to have to write the way your CAS writes in a much nicer way. So it always factors out a negative, and it's really horrible. So both of those fractions involving the root 42 have, if you expand them out, they both have negative 1. That's the a value, negative 1. And then one has negative square root of 42 and the other has positive square root of 42. So actually it's negative 1 plus or minus root 42. Okay, so we get negative a third, or negative 1 plus or minus the square root of 42 all over 3. Express your answers in form. So state the x values of the other 2 points of intersection. So I'm just going to answer the question. I didn't want to omit this because it's a solution to that equation, but I'm just going to then actually answer the question. So therefore the other 2 intersection points are, should really be the x coordinates of the other 2 intersection points, but that's okay, are x equals negative 1, maybe I can say are at x equals negative 1 plus or minus square root of 42 over 3, so it's the other 2 points. Find the total area of the regions bounded by the tangent L and y equals f of x. Express your answer in the form a root b on c, where a, b and c are positive integers. Okay, so we want to find this area here and this area here. We know that value there is negative a third. We know that that value there is negative 1 plus root 42 on 3. And that value there is negative 1 minus root 42 on 3. Okay, so we actually don't need the negative a third, because from this x value to this x value, the top function doesn't change. It's always the tangent minus f of x. So we actually don't need to break it into 2 separate integrals. The area is just going to be the integral from, but they're not symmetric, so you can't just do, they might be, but we don't know that. We don't know about this turning point. Yeah, I would calculate them as one thing. So negative 1 sorry, not plus or minus, negative 1 minus root 42 over 3, negative 1 plus root 42 over 3, and it is the tangent, which is 80x on 9 plus 41 on 27, take away the original function. Okay, let's see what our CAS gives us and see whether we need to do some work to get it to look like that. So shift plus, control divide, try it again, negative 1 minus square root of 42 over 3, and then again control divide, negative 1 plus square root of 42 over 3, and then it's our tangent. I'm going to just copy. If I press enter, it's going to go into the limit here, because that was the last place I exited that function. So if I instead press Control C up here and Control V here where I want it, and then it's minus f of x. Oops, minus f of x. If you're going to write out f of x, you must have brackets around it. That's why it's actually easier to refer to f of x than not. Okay, and we don't need to do anything with that. So that is 784 times the square root of 42 over 135, which is in the required form as it is. Alright, so again, 2 marks, 1 for setting up the right integral, 1 for giving the right answer in the correct form. Okay, let P be another function. Okay, I'm going to define that before I do anything with it. So menu 1, P of x is another quartic function, 3 times x to the power of 4 plus 4 times x cubed plus 6 times a minus 2 times x squared minus 12 times a times x, and then plus a squared. A is a real number. Okay, state the values of a for which f of x is equal to p of x for all x. Now, I wonder if, I think your CAS should solve this. F of x equals p of x, comma x, no, comma a. Okay, that's not particularly helpful. So, but however, this isn't as complex. This is pretty straightforward. So I'm just going to write out f of x here, because we know that f of x is, let me get it on my CAS so I don't have to scroll up. F of x is 3x to the power of 4 plus 4x cubed minus 12x squared. Okay, so if these two things are equal, the first two terms are both exactly the same. We need positive 6 times a minus 2 to be equal to negative 12. And in addition to that, negative 12a has to be 0 and a squared has to be 0. So I suspect that would mean that all three of those things have to be equal to 0. So I'm just going to check that. So if we had 6 times a minus 2 equals 12, dividing by 6, a minus 2 equals 2, and so therefore, it equals negative 12. So a minus 2 equals negative 2, adding 2 gives a equals 0. In addition to that, we know that negative 12a would have to be 0, and so a has to be 0, and a squared also has to be 0, so a equals 0. Okay, so regardless of which coefficient you equate, as I said, we've got, plus 0x plus 0 here. So we've essentially got 3 things, all of which confirm for us that a must equal 0. Okay. So stating the value of a for which they're equal, that happens when a equals 0. Our CAS did give us that, but it just also had that other section that could have been a bit misleading. So not just blindly copying out what your CAS says, giving it a bit of thought. Find all solutions to the derivative of p equals 0 in terms of a where appropriate. Okay, so we don't let a equal 0 from here on out. This is only for part F. So find the solutions for when the derivative equals 0. Okay, so I can do this with my CAS. I might define the derivative function, dp of x equals shift minus derivative of p of x. And so then I might solve the derivative of p equal to 0 for x. And when we solve that, so there's no need, there's a 1 mark question, there's no need to write down the equation because that's the equation we're solving. It gave us the equation. Alright, so I'm going to have x equals 1 or, and again I'm going to think about writing this out nicely. So it's negative square root and negative 1. So both of them have a negative 1, so it's negative 1 plus or minus the square root of 1 minus a. Okay, so there's my 3 solutions where the derivative is equal to 0, so 3 turning points. Find the values, or 3 stationary points I should say, find the values of a for which p has only 1 stationary point. Okay, so we'll get only 1 stationary point if these points are not defined, okay? And they won't be defined because then we'll just get x equals 1. They won't be defined if 1 minus a is less than 0. If 1 minus a is a negative number, that square root will be undefined, hence those 2 solutions will not exist and we'll only have the 1 solution. And so that happens if we add a to both sides when a is bigger than 1. So therefore, a bigger than 1, or we could obviously write a is an element of 1 to infinity. Find the minimum value of p when a is equal to 2. Okay, so let's, how am I going to do this? I'm going to find what these solutions are when a is equal to 2. Easy enough to do that just by solving this given that a equals 2. So if a equals 2, we're also only getting 1. Oh, that's because a is bigger than 0. A is bigger than 1, sorry. So we're in this group, and so therefore we only get the 1 solution, 1 stationary point when x equals 1. And so therefore let's work out what the value of p is when x equals 1. So let's do p of 1, but we also want that given that a is equal to 2. And so that is negative 13. Okay, so min p is negative 13. So again, just 1 mark, so that's enough. If p has only 1 stationary point, so that is if a is bigger than 1, find the values of a for which p of x has no solutions. Okay, so let's have a think about what's the minimum value of p. So if we have only 1 solution, okay, 1 stationary point, sorry, we have 1 minimum stationary point. When x is equal to 1, okay, and so that means that min p is p of 1, which without substituting a equals 2 into it is that. So minimum value of p is a squared minus 6a minus 5, okay, but we also know that a has to be bigger than 1, or otherwise we'll have more than 1 stationary point, and that might not be the minimum, where a is bigger than 1. Okay, so we want only 1 stationary point, which if we think back to, we've been talked through this process right back from the beginning here. Again, what we've done is we've found the minimum value of the function, and we know that we're going to need to translate it up by more than that minimum value to get no x-intercepts. I think in this case we wanted 1, so we need to think about that same logic. So here we want no solutions. Okay, sorry. So we want to translate it up by more than the minimum. Okay, and so therefore, or we want that minimum to be, sorry, we want that minimum to be above the x-axis. So we get no solutions to p of x equals 0 if min p is bigger than 0. Okay, And so that means we want a squared minus 6a minus 5 to be bigger than 0. And we also want a to be bigger than 1 still, because we need to have only the one minimum point. So I'm going to get my cas to solve that bigger than 0 for a. But obviously if a has to be bigger than 1, the negative 1 is irrelevant. And so therefore we get that a has to be bigger than root 14 plus 3. So as long as a is bigger than root 14 plus 3, it's bigger than 1, so we only get one stationary point. It's a minimum stationary point, and that minimum stationary point will happen above the x-axis. Okay, question 2. A drug X comes in 500 milligram tablets. The amount B of drug X in the bloodstream in milligrams t hours after one tablet is consumed is given by the function. Okay, I'm just going to clear my window here. I'm going to define a new function. I'm going to define B of t, and it is equal to, control divide, 4,500 on 7 times e to the negative t on 5 minus e to the negative 9t on 10. Okay, so we've got our function defined. Find the time in hours it takes for drug X to reach a maximum amount in the bloodstream after one tablet is consumed. Express your answer in the form a log e of c. Okay, so we want to maximize b. So we want to solve where the derivative of b is equal to 0. Okay, so well actually I might define my derivative as well. Menu 1, let's define the derivative of b in terms of t, and it's shift minus derivative with respect to t of b of t. Okay, so we want to solve our derivative of b equal to 0 for t. Alright, and we get t equals, I'm going to write that as 10 on 7 because it specifies the form, 10 on 7 log e of 9 on 2, where a and c are elements of the real numbers. So yes, they are both fractions, 10 on 7 and 9 on 2, which are real numbers. There's no need to confirm that that's a maximum. With CAS available to you, you can obviously have a look at your graph and see, obviously not a good scale. Having a look at here, we've also got the graph drawn here. If I make that 500 instead of 5, yeah, we can see that we have one stationary point and it's a maximum stationary point. Okay, so that is the time in hours. Then we've got the graph drawn here. Graph of b of t is shown for t 0 to 6. Okay, so got a similar just going to move that down a bit. Okay. Alright, I've got a similar picture here. So we want to find the average rate of change of the amount of drug X in the bloodstream in milligrams per hour over the interval 2 to 6. Okay, so we want the average rate of change from 2 to 6, so therefore we want the average gradient from 2 to 6. We just want rise over run. Okay, so the average rate of change is going to be the value of b at 6 minus the value of b at 2 over 6 minus 2, or you can do b of 2 minus b of 6 over 2 minus 6, same thing. Let's just get the CAS to do that for us. We don't need to work out all those separate values, just do it all at once. b of 6 minus b of 2 over 6 minus 2, one decimal place, control enter. So that is negative 33.5. Now what are the units? Milligrams per hour. Okay, so from between 2 and 6 hours, the average rate of change is negative 33.5 milligrams per hour. Part C, find the average amount of drug X in the bloodstream in milligrams during the first 6 hours after one tablet is consumed. Give your answer correct to the nearest milligram. Okay, so this is the average amount, so it's the average value of B. Okay, so average value of B is, and it's over the first 6 hours, so from t equals 0 to t equals 6. And so that is 1 over 6 minus 0, integral from 0 to 6 of b of t dt. Okay, so we've got 1/6 times the integral from 0 to 6 of b of t with respect to t. And we want nearest milligram, so control enter. So to the nearest milligram, the average amount in the bloodstream is 255 nearest milligram, so 256 milligrams. Okay, 6 hours after one 500 milligram tablet of drug X is consumed, tablet 1, a second identical tablet is consumed, tablet 2. The amount of drug X in the bloodstream from each tablet consumed independently is shown in the graph below. On the graph above, sketch the total amount of drug X in the bloodstream during the first 12 hours after tablet 1 is consumed. Okay, so obviously in the first 6 hours, we've only got tablet 1 in the bloodstream. So we're just following the tablet 1 graph. Then, oh no, sorry, not until that point. Oh, damn it. Okay, so only up to 6 hours. Okay, so to here. Then at that point we take another tablet. So we now have the amount that's remaining in the bloodstream from tablet 1 plus the amount in from tablet 2. So this is actually a nice addition of ordinates problem. So we're now essentially adding this graph on to here. So we can just start to plot out some points. So for example, when t equals 7, we want to add this amount on to here. Okay, whatever that is. So you want to sort of be able to think through, you know, it's roughly another 1 2/3 boxes perhaps, or, you know, so 1 2/3 boxes might take me up to about there. Again, we want to add this amount on top of here, so it's another bit plus another box, so maybe up to kind of here. We want to add this just more than 1 onto here. So again, just more than 1 is going to take me maybe to about there. I want to add this just less than a box onto here, so that's probably going to bring me up to about there. About maybe, I don't know, a bit over 2/3 of a box onto here. I reckon that's going to bring me about close to there. Adding, that's probably more like 2/3 of a box, probably around about there-ish. So you essentially want to kind of think through your addition of ordinates. You might want to double that bit. That looks like about 180, take me up to about 360, maybe sort of there. So plot out some points so you can essentially draw your addition of ordinates graph. You could, of course, do some algebra, come up with the new equation, get your CAS to draw it for you. That looks a bit high. Should have added, it was less than 1, shouldn't it? So it should be more down there. So something like that is what we've got happening. Make sure you don't forget to go over the tablet 1 bit. You want the total amount of drug X in the bloodstream during the first 12 hours. So over the full 0 to 12, there should be a graph drawn. Find the maximum amount of drug X in the bloodstream in the first 12 hours and the time at which this maximum occurs. Give your answers correct to 2 decimal places. Okay, so our function is just b of t from 0 to 6, but then we want to think about what's happening between 6 and 12. Okay, so if we think about, we've essentially got, if we think about this curve, if we imagine that that's b2 of t, and b2 of t would simply be b of t translated to the right by 6. So b of t minus 6. Okay, so b1 maybe. Tablet 1 translated to the right by 6 is going to give me tablet 2. And so that means that between 6 and 12 hours, the amount in the bloodstream is, so the total amount in the bloodstream, so maybe I'll call that TB, or B, no, I'll call it total blood amount in the bloodstream, is going to be B1 of, it's going to be B1 of T plus B2 of T, where T is bigger than 6. Okay, bigger than or equal to 6. It's the same. So therefore, we've essentially got B of T plus B of T minus 6. Okay. So I might call this in my CAS TB, total B. So I'm going to define a function. Total B of T, which is just B of T, which I've already got defined, plus B of T minus 6. But we're only looking at that where T is bigger than 6. We want the maximum amount of drug X in the bloodstream, so we want to maximise that. So we want to solve, well, how we want to write it, the derivative of B dash T equal to 0. Okay, so menu 3.1, we're going to solve derivative with respect to T of TB of T equal to 0 for T. Control Enter, 2 decimal places. Okay, so it's we get a stationary point at 7.78, which seems to marry with what's happening with my graph. Okay, so actually I should be peaking. I might just edit my graph here. It should be peaking part before that point. So it gets higher there and then it comes back down. Okay, so that happens when T is approximately now 2 decimal places, so 7.78 hours. Find the maximum amount of drug X in the bloodstream in the first 12 hours and the time at which this maximum occurs. Give your answers correct to 2 decimal places. Okay, good. Oh, we actually want the maximum amount of drug, the maximum amount of drug X in the bloodstream. Okay, and so therefore maximum amount is going to be BT of 7.78, which is essentially B of 7.78 plus B of 7.78 minus 6. Okay, but I can just do that with my CAS. So we want TB of, now I'm going to type it more accurately than that. We don't want to use a rounded answer to then create another rounded answer. So 779001916, I'm just typing out what I can see. And so that is correct to 2 decimal places, 400, I'll say 7 is the right 455 point, possibly too tired to be doing this right now, but anyway, 455.82 milligrams. So that's the time at which we get maximum dosage, and the maximum amount in the bloodstream is 455.82 milligrams. And we had to solve, we had to sort of come up with this function first in order to do it. So 2 marks is really only going to be for those 2 answers, but there's sort of more work than that there in that question. Question 3. Okay, so whole new question again. I'm going to clear my screen and start again. A horizontal bridge positioned 5 metres above level ground is 110 metres in length. The bridge also touches the top of 3 arches. Each arch begins and ends at ground level. The arches are 5 metres apart at the base, as shown in the diagram below. Let x be the horizontal distance in metres from the left side of the bridge, and let y be the height in metres above ground level. Arch 1 can be modelled by the function h1, Arch 2 can be modelled by h2, and Arch 3 can be modelled by h3. Okay, so Arch 1, it only has a domain from 5 to 35, and it is this particular sine function, which we can see there's a translation to the right by 5, which is how we're getting the sine function to start here. Here we're then translating to the right by 40, which is how we're starting here and here. We're going to need to work that out, but we need to translate that to the right by 75, and so A will have to be 75 before we even do anything. I haven't defined those functions. I might not need to define all three of them. Let's see how we go. Describe the transformation that maps the graph of h2 to h3. Okay, so that is getting from this graph to this graph. So from 40 across to 75, we need to go to the right by 35 units. So it's a translation. It's really important you use the word translation or dilation or reflection. Translation right by 35. It's actually meters. Everything's in meters, I think, from memory. Yeah. So it's a translation to the right by 35 meters. Okay, part C. The area above ground level between the arches and the bridge is filled with stone. The stone is represented by the shaded regions shown in the diagram below. Find the total area of the shaded regions, correct to the nearest square metre. Okay, so the easiest way to find the shaded region is just going to be to find the area of the rectangle, which is clearly 5 by 110, and then take away 3 of these. Okay, so we're going to need the total area. I'm going to just go back and define arch 1. So I'm going to define h1 of x equals 5 times sine, so dealing with trig, I'm also just looking to check I'm in radian mode, 5 times sine of x minus 5, oh sorry, I didn't mean square brackets, let's try that again, sorry, x minus 5 times pi on 30. Okay, so we've got that function defined. So the total area, total shaded area I should say, is going to be the area of the rectangle take away 3 times the area of one arch. So that means it's going to be 110 times 5 minus 3 lots of the integral from 5 to 35 of h1 of x. So we should be able to get our CAS to do all that. 110 times 5 minus shift plus, oh sorry, you want 3 of those, 3 times the integral from 5 to 35 of h1 of x. And we want nearest square metre, so control enter. That is approximately 264 nearest square metre, 264 metres squared. Okay, part D, after some more information. So a second bridge has a height of 5 metres above ground level at its leftmost point and is inclined at a constant angle of elevation of pi on 90 radians, as shown in the diagram below. The second bridge also has 3 arches below it, which are identical to the arches below the first bridge, and spans a horizontal distance of 110 metres. Let x be the horizontal distance in metres from the left side of the second bridge, and let y be the height in metres above ground level. Okay, state the gradient of the second bridge correct to 3 decimal places. Okay, so the gradient is going to be tan of that angle, so tan of pi on 90 radians. So I can just type that into my CAS. Tan of pi on 90, I'm already in radian mode. And so the gradient correct to 3 decimal places will be 0.035. Okay, P is a point on arch 5. The tangent to arch 5 at point P has the same gradient as the second bridge. Okay, so the tangent here at P is parallel to here. So it also has this gradient. Okay. Find the coordinates of P correct to 2 decimal places. Okay, so arch 5, remember, is the same as h2 of x. So I'm going to define h2 of x. h2 of x. It's just going to be h1 of x after a translation to the right by, so from 5 to 40 by 35. Okay, so that's h2. So the coordinates of P is going to be where the derivative of h2 of x is equal to tan of pi on 90. Okay, so if we solve h2 of x equal to this 4x, and it's a trig function, so we probably need to give a domain because there'll be infinitely many solutions to that. So given that we are between 40 and 70, x is somewhere between 40 and 70. Control Enter. Okay, so we're actually getting 2 points. Why are we getting 2 points in that interval? Lucky we thought a bit about does my answer make sense. So I didn't solve, I solved the function equal to tan of pi 90, not the derivative of. So I actually need to solve the derivative of, sorry. Shift minus, so what I've written on paper is correct. I just haven't done the right thing in my case. h2 of x equals tan of pi on 90, and we are solving that for x, given that x is somewhere between 40 and 70. Okay, try again. Control Enter. Okay, so we find that happens when x is approximately 54 point, we want 2 decimal places, 54.36, and so therefore we also want the coordinates, so we need h2 of 54.36. So we'll do that with our CAS again, h2 of. Now sometimes it's easier, rather than type out the decimal, I can do h2 of x given that, and then that allows me to just copy that line down, given that x is equal to that. So 2 decimal places again, so that is 4.99, correct, 2 decimal places. So therefore P has coordinates 54.36, 4.99. Okay, part F. A supporting rod connects a point Q on the second bridge to point P on arch 5. The rod follows a straight line and runs perpendicular to the second bridge as shown in the diagram on page 18. Find the distance PQ in meters, correct to 2 decimal places. Okay, so we're looking for, so we want to essentially find the equation of this line. Now, it's going to run perpendicular to the second bridge, so therefore the gradient of this line will be negative 1 over the gradient of the other line, so negative 1 over tan of pi on 90. So we've got gradient and we've got a point, the point P, and so therefore we can find the equation. We want everything, so we want to find a distance in the end. So once we've found, we need to find the equation from P to Q. We're going to then need to find the equation of the second bridge, which actually we already know because it's got a y-intercept at 5. So its gradient is tan of pi on 90 x plus a y-coordinate of 5. So we've got the equation of the second bridge. We need the equation going through PQ. We make them equal to find where Q is, and then we can find the distance between P and Q. So quite a bit to do there. Okay, so PQ, so the gradient of PQ is negative 1 on tan of pi on 90, and the point P we know has coordinates, we just found them up here, 54.36, 4.99, and so therefore the equation of the line going through PQ is going to be y minus 4.99 equals negative 1 on tan of pi on 90 x minus 54.36. Okay, so let's see if we can tidy that up a bit with some level of accuracy. So the gradient is negative 1 divided by tan of pi on 90. Okay, so the gradient is about, so it's going to be negative 28.636 x, and then we're going to have, it'll be, so it's that times that plus 4.99. So I want to do that times negative that, isn't it? So that's going to be positive. So it's that, and then we're adding on the 4.99, which we've got here. Okay, so it's plus 1561.73. So that's the equation of PQ. I'm going to define that. Menu 1.1, PQ of x equals, now I'm going to get these nice exact values, so it's going to be that times x plus this. Okay, so that's equation of PQ. We know the equation of the second bridge. Is going to be y equals tan of pi on 90x plus 5. Okay, and so we want to make those equal together to find q. So q is at point of intersection. Okay, so that is when tan of pi on 90x plus 5 is equal to negative 28.636x plus 1561.73. So I'm going to solve PQ of x, which is my line I've defined. I'm going to solve it equal to, I haven't defined the other one, so I'll type that one in. Tan of pi on 90 times x plus 5. Solve that for x. Okay, so we get x is approximately 54.29. And then we want to find the y value, which we can sub that back into, I'll do my, because I've got this function defined, I'll sub it into this one. So PQ of x, given that x is that, so that means that y is approximately 90. Okay, so this means that q is the point 54.29, 6.90. Alright, and then we want to find the distance. So PQ is the square root of, so it's the difference between the x values, which is going to be 54.36 minus 54.29 squared, plus the difference between the y values, which is 4.99 minus 6.90 squared. Alright, I'm going to try and do that a bit exactly. Alright, so let's see. I'll get those other numbers. Oops. Okay, so we want that value, take away this value up here. Okay, so that's square root of 0.0666 squared plus, I'm going to do the 4.99, which was up here, that minus that, negative 1.90719 squared. Okay, so we want that squared plus that squared. Oh, sorry, shouldn't have been a negative there. It's the negative all squared, so that. So it's the square root of 3.64181, etc., which is the square root of that. So, and we want the distance from P to Q in metres correct to two decimal places. So it is 1.91 metres. Okay, so quite a bit of work to do there, a little bit fiddly with the decimals. Given that you wanted the final answer correct to 2 decimal places, I was just trying to be cautious about not getting the points to 2 decimal places, then calculating the distance and rounding that to 2 decimal places. So, but I think probably if you just kept the points to maybe 4 decimal places, you would have then been accurate enough for your final answer. But again, you know, you've got your CAS. It's not hard to work precisely. It's a little bit fiddly, but it's not hard. Okay, so question 4. Doctors are studying the resting heart rate of adults in 2 neighbouring towns, Mathsland and Statsville. Resting heart rate is measured in beats per minute. The resting heart rate of adults in Mathsland is known to be normally distributed with a mean of 68 beats per minute and a standard deviation of 8 beats per minute. Find the probability that a randomly selected Mathsland adult has a resting heart rate between 60 and 90 beats per minute. Okay, so I'm going to let M be the Mathsland, the resting heart rate of Mathsland people. So M is going to be a normally distributed variable. So M is resting heart rate in Mathsland. M is a normally distributed variable with a mean of 68 and a standard deviation of 8, so a variance of 8 squared. And then we want the probability that a randomly selected adult has a heart rate between 60 and 90, so probability that 60 is less than M, which is less than 90. So menu 553, normal CDF, 2 is what I meant, menu 552 for normal CDF. Lower bound is 60, upper bound is 90, we want a mean of 68 and a standard deviation of 8. And we get correct to 3 decimal places, so making sure that you read the question, is 0.838. Okay, doctors consider a person to have a slow heart rate if the person's resting heart rate is less than 60 beats per minute. The probability that a randomly chosen Mathsland adult has a slow heart rate is 0.1587. Now, we could calculate that ourselves. Menu 552, less than 60, we could work it out, and it should give us that value. But they're just giving you this value so that the rest of the question is going to be too reliant on it to allow you to calculate it and potentially do the whole thing with the wrong value. But that does mean that everything will be fine if we use this rounded value, because that will be how it's expected to be used. It's known that 29% of Mathsland adults play sport regularly. It's also known that 9% of Mathsland adults play sport regularly and have a slow heart rate. Let S be the event that a randomly selected Mathsland adult plays sport regularly, and let H be the event that a randomly selected Mathsland adult has a slow heart rate. Find the probability of H given S. Okay, so essentially what we've been told by this sentence is that the probability of S is 0.29. And what this sentence tells us is that the probability of S and H, so play sport and have a slow heart rate, is 0.09. And so therefore that makes this calculation pretty straightforward, because the probability of H given S is the probability of H and S over the probability of S, which means we've got the two numbers we need. It is 0.09 out of 0.29, which is 9 on 29, but we wanted to correct to 3 decimal places. 0.09 divided by 0.29 is, to correct to 3 decimal places, 0.310. You do need to write the 0 because it's not exactly 0.31. It rounds to 3 decimal places to 0.310, but that's indicating that there is definitely more going on after that. Okay, are the events H and S independent? Okay, so if they're independent, one of the ways we can test for independence is that there's 2 ways. Either we're looking for, is the probability of H given S equal to the probability of H? Or is the probability of H intersection S equal to the probability of H times the probability of S? Now, this probability up here that we've got, that's the probability of H, 0.1587. Okay. And so that is not the same as the probability of H given S, and so therefore they are not independent. Okay, so since the probability of H given S does not equal the probability of H, okay, in fact I might state those because I haven't actually stated this clearly. So we know probability of H is equal to 0.1587, probability of H given S is equal to 0.310. Therefore, since the probability of H is not equal to the probability of H given S, the events H and S are not independent. Okay. Part C. Find the probability that a random sample of 16 Mathsland adults will contain exactly one person with a slow heart rate. Give your answer correct to 3 decimal places. Okay, so we need another variable. So let's say X is the number of people with slow heart rate. And we know that X is a binomial variable. We've got a sample of 16 people, so n is 16, and the probability that one of them has a slow heart rate, given that they're from Mathsland, is 0.1587. Okay, and we can use that random value because that's what's expected here. We want to know the probability that in a random sample of 16 adults there'll be exactly one person, so the probability that X is equal to 1, and we want to give our answer correct to 3 decimal places. So menu 55A we can use for Binomial Pdf. We've got 16 trials, probability of success is 0.1587, and the X value is 1. Okay, correct to 3 decimal places, this is 0.190. Again, you must have the 0. It's not exactly 0.19, and so therefore there's more going on afterwards. It's just to 3 decimal places. It rounds to 0.190. Please note that there's 2 marks here, so you do need more than just stating the answer. You do need the setup. What is the variable and how is it distributed? It's binomial, and it has n is 16 and p is 0.1587, and also defining what the variable is. Okay, part 2. For random samples of 16 Mathsland adults, p hat is the random variable that describes the proportion of people who have a slow heart rate. Find the probability that p hat is greater than 10%, correct to 3 decimal places. Okay, so p hat is equal to x divided by 16, okay, x being the variable we defined in the previous question. So if we want the probability that p hat is greater than 0.1, that is the probability that x is greater than, so x is 16 times p hat, so x is greater than 0.1 times 16, x is greater than 1.6. Now given x is a discrete variable, that means the probability that x is bigger than or equal to 2 is what we want. And then we want that to 3 decimal places, so menu 55B for Binomial Pdf. We have 16 trials, probability of success is 0.1587, the lower bound is 2, greater than or equal to 2, and up to 16. Okay, so that is 0.74. We want 3 decimal places again, so 747. Okay, for random samples of n Mathsland adults, p hat n is the random variable that represents the proportion of people who have a slow heart rate. Find the least value of n for which the probability of p hat n being bigger than 1 on n is bigger than 0.99. Okay, so I'm going to keep using my x variable. It's still the number of people with a slow heart rate, but now x is a binomial variable where n is unknown. Okay, we don't know how big our sample should be. And p is still 0.1587. Okay, so we want the probability, and the other thing to note is that p hat of n is x divided by n, which means that x is n times p hat of n. So we want the probability that p hat n is bigger than 1 on n to be bigger than 0.99. So that is the same as the probability of x being bigger than, so x is n times p hat n, so it's the same as x being bigger than 1, has to be bigger than 0.99. Okay, which means the probability that x is less than or equal to 1 has to be less than 0.0, less than or equal to 0.01. So we want to use inverse binomial n, menu 5, 5, and I forget the letter reference, D. The cumulative probability is 0.01. The probability of success is 0.1587. The number of successes is this maximum x value here, which is 1. And we can display our answer in matrix form if that helps, just to see, but up to you. So this tells us that n needs to be 39. If we did the display our answer as a matrix, let me just do that again. So 5, 5, D, cumulative probability is 0.01, P is 0.1587, probability successes is 1. Then if we do the matrix form, it'll tell us, right, when n is 38, the probability is 0.011. So when n is 39, that's the first time the probability is actually less than 0.01. Okay, so n needs to be the least value of n, so n needs to be at least 39. Okay, so n has to be bigger than or equal to 39 for that to be true. Therefore, least value of n is 39. Okay, part D. The doctors took a large random sample of adults from the population of Statsville and calculated an approximate 95% confidence interval for the proportion of Statsville adults who have a slow heart rate. The confidence interval they obtained was 0.102 to 0.145. Determine the sample proportion used in the calculation of this confidence interval. Okay, so the sample proportion p hat has to be halfway between. It has to be in the middle of the confidence interval. So it has to be 0.102 plus 0.145 divided by 2. So 0.102 plus 0.145 over 2. The sample proportion must be 0.1235. Sorry, I should have clarified in 2020 due to the change in syllabus. Bits of this question aren't relevant. So A, B and C all relevant. A and B all relevant. C is relevant. C part 2, so not in 2020. That wouldn't be in 2020. This wouldn't be in 2020. This one not in 2020. So parts 1 and parts 2 here won't be in 2020. I'll assess when I get beyond that, but looks like not part E either. So quite a lot of this paper not relevant to 2020. Part 2, explain why this confidence interval suggests that the proportion of adults with a slow heart rate in Statsville could be different from the proportion in Mathsland. Okay, so remember the proportion of people with a slow heart rate in Mathsland was found to be 0.1587, I think? Yeah, 0.1587. Now, 0.1587 isn't even within the 95% confidence interval. So that would suggest that it's pretty unlikely that the proportion of, the actual proportion of those with a slow heart rate in Statsville is the same or similar, it is the same as that in Mathsland. Okay, so for Mathsland, P is equal to, and it's not P hat, it's P. P is 0.1587, which is not within the 95% confidence interval. for Statsville. This suggests that P in Statsville will be different to P in Mathsland. Because we would expect the confidence interval to capture the actual population proportion with 95% confidence, and the fact that the population proportion for Mathsland isn't even within that confidence interval perhaps suggests that Statsville's p-value is actually different to that of Mathsland. Okay, every year Mathsland Secondary College students hike to the top of a hill that rises behind the school. The time taken by a randomly selected student to reach the top of the hill has the probability density function m with this rule. Okay, so probability density functions also not in the syllabus for 2020, so part E also not relevant in 2020. I might define my probability density function, define m of t equals, I won't bother about the bottom half, so control divide 3 on 50 times t on 50 all squared times e to the power of negative t, so I'm just going to bracket around that, t on 50 all cubed. Okay. Find the expected time in minutes for a randomly selected student from Mathsland Secondary College to reach the top of the hill. Give your answer correct to 1 decimal place. Okay, so the expected time is going to be the integral from 0 to, your CAS is fine if you write infinity there, it's not strictly correct. So I'm going to write it as the limit as k approaches infinity, integral from 0 to k of t times m of t dt. Your CAS, however, will let you put infinity in the limit of the integral, although it's, strictly mathematically not quite correct. So 0, since we can't actually substitute infinity, we're taking a limit. 0 to infinity of t times m of t dt. Okay, so that's going to give us a t value, expected time of, now we are in, what units are we in here? T is given in minutes, we want the expected time in minutes correct to 1 decimal place, so 44.6 minutes is the expected time. Okay, students who take less than 15 minutes to get to the top of the hill are categorised as elite. Well, given that their mean time is nearly 45 minutes, less than 15 minutes certainly would be elite. Find the probability that a randomly selected student from Mathsland Secondary College is categorised as elite. Okay, so the probability that someone is elite is the probability that their time is less than 15 minutes, which means it is the integral from 0 to 15 of our probability density function. So just be careful with this. It did note in the examiner's report that a couple of people had clearly calculated the integral from 0 to 15 of t times m of t, and I suspect that was a CAS issue, not editing their previous calculation. And we want correct to 4 decimal places, so control enter, correct to 4 decimal places, that is 0.0266. Okay, again, not relevant in 2020, part F. Part G, the Year 12 students at Mathsland Secondary College make up 1/7 of the total number of students at the school. Of the Year 12 students at Mathsland Secondary College, 5% are categorised as elite. Find the probability that a randomly selected non-Year 12 student at Mathsland Secondary College is categorised as elite. Okay, so I'm just checking what the definition here was. So this is for not just for year 12, it's a probability density function, so that's for everyone. Okay, so this is the probability that any student is categorized as elite. So we want to work out what's the probability that a non-year 12 is categorized as elite. So if you think about, you can have someone they can be a year 12 or non-year 12. And then they can be elite or not elite. Elite or not elite. Okay, so what do we know? Year 12 students at Mathsland Secondary College make up 1/7 of the total number of students. So we've got 1/7 there and therefore 6/7 here. Of the Year 12 students at Mathsland Secondary College, 5% are elite. So 0.05. We want the probability that a non-Year 12 student at Mathsland Secondary College is categorised as elite. So we want to work out this X value here. Now we know the total probability that someone is elite. So the probability of being elite, if we look at the tree diagram, is 1/7 times 0.05 plus 6/7 times X. But we already know that that probability should be equal to 0.0266. So we want to solve that equation for X. So menu 3.1, we want to solve 1/7 times 0.05 plus 6/7 times X has to be equal to this probability we found in the previous question. We want to solve that for X, and that tells us that X needs to be approximately 0.0227. Okay, and moving on to question 5, the final extended response question on the paper. So consider functions of the form f and h. Alright, I'm just going to clear my scratch pad. I'm going to define, I haven't cleared my variables, but that's okay. Oops, define f of x equals control divide 81 times x squared times a minus x over 4a to the power 4. Okay, so that's f. Let's also define h. H of x is equal to 9x on 2a squared. Okay, find the coordinates of the local maximum of f in terms of a. Okay, so we're going to solve f dash of x equal to 0. I might define my derivative of f. Derivative of f is derivative of f. Okay, so we want to solve df of x equal to 0 for x. Okay, and we find that the derivative is 0 when x is equal to 2a on 3 or 0. Now if we think about this function, this is just 81 on 4a to the 4 with its number times x squared times a minus x. So this is a cubic function, a negative cubic function with a turning point at 0, an x-intercept and a turning point at 0, and an x-intercept at a. That's what f looks like. And so therefore the coordinates of the local maximum isn't the 0. The 0 is clearly a minimum, thinking about that. So this one's the max and this one's the min, thinking about the graph. And so therefore we want to work out f of 2a on 3, f of 2a on 3 is 3 over a. Therefore the local max is at the point with coordinates 2a on 3, 3 over a. Okay, find the values of x of all the points of intersection between the graphs of f and h in terms of a where appropriate. Okay, so we want to look at when f of x equals h of x. So we are solving f of x equals h of x for x. Okay, and that tells us that x equals 2a on 3, a on 3, and 0. Okay, so that means that they intersect at the maximum and at 0, and also halfway along there. So they intersect at, that maximum point and that point, which is halfway. Because a on 3 is half of 2a on 3. Determine the total area of the regions bounded by the graphs of f of x and h of x. Okay, so I've got my rough sketch up there, but what we've basically got happening here is we've got our cubic function. We know that that is 2a on 3. We know that halfway along there is a on 3, and we know that they intersect at all three of those points. So that's y equals h of x, and this one's y equals f of x. So we've got some good symmetry here. We could probably assume that they're the same area, but just to be safe, you've got your CAS, there's no reason you could just do those two separate integrals, but it is going to be, there is symmetry there. The fact that this point is halfway allows us to kind of think that through. So the area is going to be the integral from 0 to a on 3. That would be h of x is the top function minus f of x, plus the integral from a on 3 to 2a on 3 of, in that case, f of x is the top function minus h of x. Okay, so let's work that out. Shift plus 0 to a on 3 of h of x minus f of x dx, plus another integral from a on 3 up to 2a on 3 of f of x minus h of x. dx, which is 1/8. Let's just check if we had just worked out one of these integrals, it's 1/16. So yes, we could have just doubled one of them if we thought a bit about the symmetry, which we had done. But as I said, you've got your CAS, it's not too much harder to find the total area, just to be sure. Okay, consider the function g, okay, which has the same rule as f, I think, doesn't it? Let me just call up f of x in my CAS. Oh, sorry. F of x is, it's taken out the negative, but yes, it's the same function as f, it's just now got a restricted domain. So just so I don't get confused with my CAS, I think I'm also going to define g of x as being that same thing. A is a positive real number. Evaluate 2a on 3 times g of 2a on 3. Okay, get our CAS to do that. 2a on 3 times g of 2a on 3. We actually already know what g of 2a on 3 is because we've worked out the stationary point. I think it was 3 on a from memory. Yeah, and that makes sense. So this is 2a on 3 times 3 on a, which is why we're getting 2. Find the area bounded by the graph of the inverse of g, the x-axis, and the line x equals g of 2a on 3. Okay, let's think about, so remember g of x is just this part of the cubic. Okay, so remember that's 2a on 3. This is 0. This halfway point was a on 3. And when we find the inverse function, so this was the point 2a on 3, this was 3 on a. When we find the inverse function, it's going to essentially be, I'm just trying to think about, well, 2/3 of A, it doesn't really matter, but it's going to go through the same point. Alright, so if that's the inverse, and we want, and thinking about this, that is G of 2A on 3, okay? So therefore, this is the point G of 2A on 3, 2A on 3. So we're finding the area bounded by the graph of the inverse, the x-axis, and the line, and that line there. So we want to find that area there. That's what we want to find. But actually, we don't need to find the inverse function. We could, but that's going to be exactly the same as this area here. Okay. So it's going to be the same as that area, which is essentially that square, which is just what we worked out in the previous question. So the area of the square, which is going to be 2A on 3 times G of 2A on 3, okay, which we've already worked out as being 2, and then we're going to take away the integral from 0 to 2A on 3 of G of x. So this is just 2 minus that integral from 0 to 2A on 3 of G of x dx is 1. So it's 2 take away 1, and so the area is 1 square unit, which actually means, so what that actually means is that's half the area. So therefore, and that also makes sense because I haven't drawn a very perfect graph, but remember the straight line cut through there and cut through there. So if that straight line must be essentially equivalent to y equals x. It's just, if we mirror it in that line, we've got nice symmetry. Therefore, the pink area, the pink area, which includes this bit here, is going to be exactly the same as this bit of area in under here. Okay. Find the value of A for which the graphs of G and the inverse of G have the same endpoints. Okay, so that will happen if the coordinates are equal to each other. So that will happen if 2A on 3 is equal to 3 on A. They'll have the same endpoint if when you switch x and y, you still have the same point. So if we solve that, I can probably do that quickly by hand. 2A on 3 equals 3 on A. Solve for A. We find that that happens if A is equal to plus minus 3 root 2 on 2. Now, do we have something about A having to be positive or negative? A is a positive real number. Okay, and that's why it says find the value. So A equals 3 root 2 on 2, since A is bigger than 0. Okay, find the area enclosed by the graphs of G and the inverse of G when they have the same endpoints. Okay, so when they have the same endpoints, we're going to get exactly what I said here. We're going to get this perfect thing here, where if they have the same endpoint, it's all going to be perfectly square. So if that's the point, 2A on 3, 2A on 3, or 3 on A, 3 on A, which would be the same thing. And if they have the same endpoint, then when we draw the line y equals x, that also goes through that point and this point. And so then the inverse function is the mirror image of this. So that's the inverse of G. The blue function is G. And if I draw that line in something else, the green line is y equals x. Okay. The area enclosed by the graphs of G and inverse of G when they have the same endpoints. We could think about it in a couple of different ways. We could probably just find this bit of area here and multiply it by 4. Okay. So we already know that that is going to be halfway along. That's going to be at a on 3. And so therefore the area is going to be 4 lots of the integral from 0 to a on 3 of x minus g of x. And that way we don't even need to find out the inverse function. So if we do 4 times shift plus 0 to a on 3 x minus g of x with respect to x. Still got that in terms of a. Oh, we know what a is, sorry. So when the endpoints are the same, we actually know what a is. So therefore, if a is 3 root 2 on 2, 2/3 times 3 root 2 on 2, that's root 2 root 2. Which means that this will be root 2 on 2, half of that. So actually this should be, sorry, that. Okay, let's fix this. Root 2 on 2. Oh, I need to define g of x has still got, okay, so we need to define, I forgot my, let's just go back and do this, given that a is equal to, I'm just trying to work out the quickest way to do it with my cards, given that a is equal to 3 root 2 on 2. There we go. Okay. So it's essentially, yeah. So g of x is now the, yeah, you have to substitute a equals 3 root 2 on 2. So the total area is a quarter just by using the symmetry, given that if they meet at the same endpoint, that endpoint is at on y equals x, they also meet at 0, 0, which is also on y equals x, therefore they're symmetric about y equals x, and we can then just use the symmetry, and we don't even need to find out the inverse function. Okay, that brings us to the end of the exam. I hope some of that was helpful to you.